Hi, and welcome back to the next video in our series on installing and configuring Snort. In our last video, we installed Snort and set up some directories for it. If we look under var snort, we set up an instance1 directory and an instance2 directory. These are going to be the ones that we're using today as we advance a little further into our Snort configuration. I'm going to go back to root, where I've actually gone ahead and added a few different scripts here. The first of which we'll look at is the bridge start. And what this does is just a simple shell script. It's going to use ifconfig to bring up eth1 and eth2 in promiscuous mode. And then it's going to create a bridge interface called br0. And it's going to add eth1 and eth2 so they're both part of br0. And then it's going to bring up the bridge interface. And I'm going to go ahead and make each of these scripts that I've added so that they're executable. Next, we're going to look at CPU Affinity.sh, which is a script that we'll actually have run after Snort starts up. And what it's going to do is it's going to look for any process named Snort. In this case, by the way, we are going to be doing 2 instances of Snort on the same machine. So what it's doing is it's starting at CPU core 0. This machine does have multiple CPU cores. This could be multiple physical CPUs, multiple cores, whatever you have. And it's going to look for any process named Snort, and it's going to assign it to that CPU, then increment this by 1 and go through for the next Snort process. Starting at 0, what's going to happen, and I'm going to start up top here to show you. I'm going to just hit the number 1 in the top output to show all the different CPUs or cores. And remember, we start with CPU 0. So this machine has 4 different CPU cores. And what we're going to do is we're going to tell the Snort process with CPU Affinity. After it starts up, we're going to run the CPU Affinity script. And the first Snort process is going to get assigned to CPU 0. And the second Snort process is going to get assigned to CPU 1. So each Snort process is dedicated to the CPU to which it gets assigned. And we're also going to modify the Lilo configuration in Slackware so that nothing else will use these CPUs. They will become Snort-only CPUs, leaving all remaining system tasks to be performed by, in this case, CPU 2 and CPU 3. Okay, let's look at nfq start snort.sh. And you can see at the end of this script here, we do run the CPU Affinity script as part of this. This one is going to start up both of our Snort instances. Important things here, we tell it to locate, we tell it to start up Snort, which is user local bin snort. Then we tell it where to find the DAC, which in this case is user local lib DAC. We specify several different Snort options here. An important one is we tell it to use DAC NFQ, and with a snap length of 65535. Now you'll notice that we don't actually, if you're familiar with Snort, you'll know that in the commands to start it up, you can specify a user and group. So basically, Snort would start up as root, and then drop privileges down to the user and group you specify. We don't do that here. And the reason for that is the NFQ DAC module works hand in hand with Iptables, and you're going to need root privileges to be able to work with Iptables. So when working with NFQ, your snort instances are going to need to stay running as root. We specified the snap length of 65535 because that's going to be possibly the largest packet size that snort will inspect. Reason for that is all the packets that make it to snort have already run through Iptables, or they're going to run through Iptables first. So there won't be any fragmented packets. Everything's going to be, we'll say, defragmented by Iptables before it's handed to snort. And we've got a few other options in here. For instance, we're going to write performance data. By default, it runs every 5 minutes or 10,000 packets to a file called var snort instance 1 now. And for the second process, it's going to be instance 2 now. The DAC variable here, the DAC var q equals 0. It's the NFQ q that this particular snort instance is going to operate on. On this one it's q0, on this one it's q1. And then we're using the ampersand at the end to background them. Now you may be thinking there's a -D option that will demonize the process, so you don't have to use the ampersand. There's a reason that I'm not using that, and we'll cover that more when we get into file capture. And it may not be true. I haven't actually tested it in a while. I think I ran into the issue back in the 297. It was either the alpha or the beta release. I noticed that file capture wasn't working properly if I was using the -D to demonize it. So at that point, I just changed to backgrounding the processes instead of using the -D, and I've been running that way ever since and haven't gone back to see if that's still an issue in the final release of 297. But anyway, this is what will start up snort. That leaves us with the last script here is Iptables Start. And we actually have a lot going on here. I'm actually going to edit that in VI. And add a shebang here. It's a pretty straightforward Iptables setup. We're starting at the beginning, just basically telling it to drop any packets that contain all these flags. You should never really see these, so this is just a simple drop, and this is for ETH0, so these would be packets seen on your management interface. So this is just a pretty basic setup. We're going to drop these. And then down here we start with the Iptables A input rules for ETH0. This one, for example, we're just accepting, we're allowing ping requests to the management interface. And also don't forget to put in a rule here for port 22 or whatever port your SSH is running on. And make sure it's set to accept. Commented out a rule here. We don't need it for right now. We may add it back in later as we cover the topic. But this is just a rule to allow SNMP requests to the management interface of our snort box on port 161 UDP. Okay, we're also on ETH0 allowing related and established connections. And then we, if it doesn't fit into any of the criteria above of anything we have accepted for ETH0, then this rule tells it to drop. So if a packet comes in and doesn't match any of these accept rules, doesn't match any of these drops up here, if it makes it all the way down to this part of the chain here, it's going to get dropped. So if you have something you need to allow to connect to ETH0, then be sure to put it up here with the rest of these rules. And then down at the bottom, we're forwarding anything from NFQ. So this is basically going to be all the traffic that's involved with ETH1 and ETH2. And remember, they're both part of BR0 now. So basically think of this in terms of if it's traffic passing over BR0, then this rule will send it to snort. We have the queue balance option in Iptables followed by 0:1. And this is what's going to tell Iptables is going to balance the flows that get sent to snort. And what the queue balance option does is it tells it to balance between these. In our case, these are going to be our snort queues. So remember when we looked at the snort startup script and we set a DAC variable q equals 0 and q equals 1? Well, that's what this means. So it's going to balance between those two queues. This could be a range. So if you had more than 2 instances of snort, you could assign DAC variables to each instance of snort. Let's say you have 3 instances. You would start with 0, then add q equals 1 and q equals 2. And this is just a range separated by a colon. So with 3 instances, you would change this 1 to a 2, and it's going to balance between 0 from q0 to q2. Now, queue bypass is a neat little feature. If you don't have queue bypass put in, and let's say one of your snort instances crashes, or you take it down and forget to start it, or potentially both your snort instances or all of them are down, well, Iptables is going to continue to send traffic or try to send traffic to those instances. But since there's no snort running there to accept the traffic is just going to hit the floor. It's not going to make it through your sensor and onto its on its merry way to its destination. What queue bypass does is it's sort of a software bypass in which even if snort's not running, queue bypass, if that's enabled here, will still allow your traffic to pass through the wire, meaning it will just get to where it needs to go uninspected by snort. And if having connectivity and uptime is your goal, and security and inspecting with snort is sort of a secondary thing, then you may want to have this enabled to avoid any outages that could occur if snort, for whatever reason, is not running. Now, supposing for a moment that there is traffic that you don't want to inspect that's going to be coming in to ETH1 or ETH2. It's part of what BR0 is seeing, but maybe it's backup traffic, something you don't need to have inspected. What you can do is actually create your Iptables rules here. For instance, let me clear this out just a little. And you'll specify interface BR0. And then you could say a source of, let's say 192.168.1.10. If you wanted to, I believe you could also do a CIDR range here. Let's say the 192.168.1 Class C network, the /24 range. So that would be anything originating from these addresses, because I have the -S for source. And you could just do a -J accept here. Remember, these rules are read in a top-down fashion, so traffic comes in, it's going to start at the top and go down until it finds a match. So traffic seen by BR0 from this source range here is going to get accepted at this point. It'll be passed through. It will never make it to snort for inspection. It'll be, it's kind of like saying the traffic is trusted. We don't need to inspect it. We just want to let it go right through the sensor. And you could also do the same for destination. If you had other traffic that you don't want to make it to snort, but you definitely don't want to allow, you would just create a drop rule. If you don't add rules here, then basically everything that the sensor sees on its what we're calling sensor interfaces, ETH1 and ETH2, will be passed to snort for inspection. So just to remember, up in this section here, you'll include any rules for your management interface that you want to add. And then down here, above this last rule, you'll include any Iptables rules to control traffic that you don't, for any reason, want to get sent to snort. Like you want to allow it through, you want to drop it, but you don't want to waste snort's time with it. And then when it hits this last rule, it's going to snort for inspection. So I'm going to save and quit out of that. And we actually have a few more directories to create, which I don't think we did already. So I'm going to do a make directory etc snort rules, etc snort rules IP lists, and then we're going to touch a bunch of files. Actually, we're going to create a file called etc snort rules snort.rules, etc snort rules local.rules, blacklist.dlf, whitelist.wlf, the ones that we care about right now, I wanted to go ahead and create all of them, but we're going to be focused on snort.rules, which is going to contain all of our, obviously, our rules for snort. Local.rules is going to be there to separate rules such as the ones provided by the VRT, or now they're referred to as Talos, from any rules that you've created yourself or gotten from external sources. If you create a rule, I suggest creating it in the local.rules file, or if you're not using something from the VRT or Talos, another that you're downloading rules from a separate rule repository, such as emerging threats, you might want to stick them in local rules as well. Actually, emerging threats is a bad example because that is going to be part of our snort.rules, and that'll come in later when we're configuring pulled pork. But yeah, pretty much if you write your own rules, stick them in local rules, keep them separate from snort.rules. And then we have our blacklist and whitelist, and this is for IP reputation. Okay, let's do a quick change directory into etc snort. And let's edit our snort.conf. We're not going to go through the entire file right now, but we are going to look at things we're going to want to do. It even gives you sort of an outline of steps here, such as set the network variables. With the variables here used by snort, you want to make these as specific as possible. I'm going to leave it set to any. while we do this, but at the very least, assuming you don't change any other variables, change HomeNet. HomeNet should be set to the network that you're protecting with this sensor. So suppose I have all the machines behind my sensor are on the 192.168.1 .0/24 network, then that's what I'm going to put in here. And, this should not include any machines that you're not protecting with that sensor. Only the addresses that you're protecting with this snort sensor. External net can be left to any. Some people like to do this, which tells it not anything that's defined in HomeNet. Now this really only makes sense if you have HomeNet set to a specific address or CIDR block. We're going to leave it set to any. And what that'll do is it tells us that it's possible for the sensor to fire rules which are written looking at something, let's say external net to HomeNet. Even if the machine is looking for any external net address here, so even if the machine is on your protected network and talking to another machine on the protected network, it's still possible for that rule to fire. And that might not be the case if you did not HomeNet. I hope that makes sense to you. Moving on, we've got things like DNS servers, SMTP, web servers. And by default, they're set to the same value as HomeNet. So these are going to be set to any. Again, I strongly recommend you set HomeNet to an actual value. And even then, you'll probably want to take out HomeNet for these. For example, if you did a /24 or a /16 network range for your HomeNet, that's a lot of machines, and I bet they're all not DNS servers or SMTP servers, web servers, etc. Make these as specific as possible. When we get down to a rule path here, we're going to take out one of the dots here. We're going to leave that just dot/rules. Same there. All I did was remove one of the dots. And again, we're not going to configure everything right now. We're just going to look through and anything that jumps out at me. We're setting a lot of our details from the command line in the snort startup script, so things like, I think I saw snap length up here. We don't need to set that. We're setting it on the command line when we start snort. And I'm not concerned about a BPF file, which uses basically TCP dump Berkeley packet filter style notation. You would typically use it to tell snort to not inspect that type of traffic, or not inspect traffic that matches a certain criteria, such as being from a certain host or to a certain host. But the way we're using Iptables, instead of using a BPF, you're better off to allow, let's say if there's traffic you don't want to inspect, do that in Iptables. Don't put the burden on snort in a BPF to figure out what's not supposed to be inspected. And we are going to be installing the sensor to run in inline mode, and by default inline normalization is enabled. And now we're getting into the preprocessor config. I'm going to just skip down a little further to DNP3 and Modbus. This is typically going to be related to SCADA systems. I don't have any, you probably don't. So I'm just going to comment out all the lines related to Modbus and DNP3 because we don't need this. Okay, for the reputation preprocessor, let's go ahead and change the whitelist rule location to whitelist path IP lists whitelist.wlf, and we're going to do something very similar for blacklist location. Okay, our output type, we'll just put it right here. We're going to say output unified 2. File name, snort-unified. And let's see what other options we want to include here. I think we just want to go with 128. Okay, and site-specific rules, we have include our rule path, local.rules, which is fine. You can comment these out or delete them. I'm going to go ahead and delete the rest of these. Down to this point here. And I'm also going to say include rule path snort.rules. Don't really care about any of this. This is fine, and include threshold.conf. And I'm going to uncomment the preprocessor perf monitor line. Time 300, so it's 5 minutes. File, let's take out the file name. So we should have time 300, packet count 10,000, which is the default. We don't put the file name in here because we're specifying it should write this to the now file in each instance directory, and we're specifying that from the script we're using to start up Snort. I'm going to go ahead and save and quit. That's all the config I want to do for right now. What I would like to do is start up Iptables. Okay, and the Iptables -L shows me that it did take the configuration for Iptables. We can see the rules that are in place here. And I'm going to do Iptables save. I'm going to direct it to the current directory, which is the root directory, and I'm going to call it iptables config. So if I do a less on iptables config, this is the current configuration that I want to load. Now I'm going to edit the etc rc.d rc.local file because, hey, I already said in the Snorby video, that's where I like to put things. Feel free to write your own startup script. You can probably make it look a lot nicer than this, but this is what I'm going with. We're going to tell it to run root bridge start.sh, and then use user sbin iptables -restore to load in root iptables config. And I'm just going to put a sleep of 3 there just to make sure there's time to get our iptables settings in place. And then let's run root nfq start snort.sh. Give me 1 second. Let me just see what I actually named that file. nfq start snort.sh. Okay. I thought I might have named it something differently and wanted to make sure everything matched up here. So that's good. We'll save and quit that. Let's make sure that there's nothing wrong with our snort configuration. I'm going to clear the screen and run snort with a -c and point it to our config file, which is etc snort.conf. And we're going to use a -T to tell it to test this and let us know if there are any errors. You would want to do this anytime you make changes to the snort.conf file to make sure that those changes are actually going to work and Snort's not going to bomb out when you try to start it. In this case, we did get an error. Could not staff the dynamic module path. Now, we haven't installed pulled pork and run it yet, so there are some things that we may need to comment out for now. And this could not open. You know, just for the test, I'll go ahead and just make... we'll go ahead and make the directory varlog snort. Our command line options for starting snort are actually going to tell it to write the unified files to each instance directory we've created, but I didn't specify anything about that here, so that's why it's thinking it needs to be able to write to this snort directory under varlog. Okay, if it's good, you should see the snort successfully validated the configuration line, followed by a snort exiting. Okay, so you should be running this on a Slackware system like I am. So one of the last things we need to do here is edit etc lilo.conf. And we want to find the append line and add ISOL CPUs equals 0, 1. Now we're using CPU affinity with snort, and remember I said earlier that we would be telling Lilo The system at boot time, there should be no other processes using CPU cores 0 and 1. We're dedicating those to our snort instances. So this is how we're going to tell it, let's isolate these CPUs from the rest of the system. And we'll save that. And then you should run sbin lilo. And it's normal to get one warning issued here. So on reboot, we should see that these CPUs here should only be available for snort. And just to make sure everything's going to start up okay, I'm not actually going to do a reboot here, but I am going to run these scripts in the order that they would run that we've specified in our rc.local file. I'm going to run bridge start. And see that BR0 did get created. Iptables still has my config loaded. So now we'll run nfq start snort.sh. And remember, inside of this script, we're calling a CPU affinity. So we'll make sure this starts up okay. Now we don't really have any rules loaded, so you'll notice there's not a lot of memory utilization going on here. But what we can see is that we do have 2 snort processes running. I'm going to make another script called rotatestats.sh. And you'll notice I'm using bin bash, and notice this is actually not a single quote, this is a backtick at the beginning and another backtick at the end. And we're basically issuing the kill command with the sig user2 flag, and we're running it against all our snort instances with a PID of snort. What that's going to do, going to rotate the performance statistics. We're going to be outputting that to inside of each instance directory. We're writing performance data to a file called now. What this kill command is going to do is it's not actually going to kill or interrupt the snort process from running, but it is going to rotate those stats. It's going to, when we run that, it's going to take whatever's in there and put it into a file that's named for whatever the day's date is. And then a new now file is going to start collecting data. And I like to run that at midnight. That way, we only have one day's data in each now file, with now being the most current. And remember, we are set to UTC time, so you'll need to adjust that appropriately here. So what I'm going to do is make a comment here, run snort perf stats rotate. I'm going to say do it at midnight on every day, week, month, blah, blah, blah. And that should do it. Okay, it's listed there when we do a cron tab -L. Still got my snort processes running, so that's good. And if you want to look at, if I could type correctly, if we want to look at varlog messages, you'll see in here is where the startup information for each snort process gets written to. So this is a great file to look for errors if there's a problem starting snort or if it exits immediately. But in this case it looks good. Let's check our instance1 directory. And you'll see we actually have some files here now. The snort socket, the PID and PID lock, the first unified file, nothing's in it yet, and you'll notice that it gets appended with this strange number, which is actually the Unix epic timestamp. So for instance, if we did a date-d at and paste that timestamp in there, we get a more readable format. This is telling us that that timestamp was for Saturday, December 27th at 43 minutes past midnight UTC time. And the now file also has our performance statistics. You'll notice right away this is a CSV or a comma separated values file. So you could actually SCP this file off of here and load it into, let's say, a spreadsheet software, something that'll recognize and separate those comma separated values into different columns in order to let you sort and manipulate the data and see things like, is snort dropping traffic? There's a drop rate in here. That's not good. You don't ever want to see snort dropping traffic. There's several reasons, performance reasons that can cause that to happen. We'll discuss those in a later video in this series. But yeah, things to look out for are drop rate, and you can actually see how many megabits per second that snort is analyzing. Some neat things, and we'll also go over better ways to look at this rather than using something like spreadsheet software. And instance 2 should have very similar files for its instance. So, in conclusion, we added a lot of files here today, and I'll be sure to include links to each of these scripts in the description of this video. That way you can download them, and I may have been moving kind of fast. You may not have been able to note everything inside of each of these scripts. So I'll have them set up as basically like templates for you to use. And just look for those in the description of the vid. And stay tuned until next time, and we'll move along a little bit more with this snort setup. And hopefully in the next few vids we'll get everything completed, and we'll start up our the Ubuntu machines that I have on either side of the sensor and do some testing and make sure things are working okay. So stay tuned for that, and thanks as always for watching.